there. Okay, welcome. Happy Thursday. I think it's Thursday. Yep. Happy Thursday. And I feel like there was something I was going to mention kind of administratively, but can't remember. Oh, except that I realized I was scrolling through our Moodle page, and I realized I haven't posted any assignments. So you've had lab assignments, and that's good. That's the focus. And so I should probably post some assignments as well. So I'll get to work on that. It's just been a little bit of a busy week, but I feel like this is going to be that kind of term for me where it's just like crazy. But that's okay. It'll be over one way or another, I guess. So what I want to do, unless you guys can think of something, but oh yeah, just a note. So for the lab tomorrow, there's going to be, because making videos is really boring when no one is there to interact with or kind of play around with. So so I will make a video to show you how to make sure that everything is, it's just me talking to myself for hours. I will make a video showing how to get set up with Python and stuff like that, and just to kind of get you started. But my what I want to do is just post the instructions. And I'll try to make them not so wordy, but maybe I'm not good at that. But all we're doing is we're recreating the code in the textbook, right? And the output in the textbook. But I also want you to think about things and tell me, like, when would I use this? When would this be useful? Right. And just so we can start to kind of make that connection. Okay. And so that's my plan for the lab tomorrow. So the video itself will be very short, but then there will be instructions. So I'll just kind of show you the beginning and then kind of say, now do the rest of the chapter. Okay. And so, so for the lab this week, okay, I'll post a video that gets you started. Oops. I will post a video and instructions. So usually, I mean, I make the videos because I hear from students that they prefer to watch a video over reading notes. But if you just want to read the notes, that's all, it's all there. So I'll post a video and the instructions to get you started, and then you'll continue with the rest of the chapter. And so that'll be more clear with the instructions, hopefully. So I'll post the video and the instructions to get you started. And then you will keep working, and the instructions will say what to do. And then you will keep working through the chapter. So I'll do the first one or two with you, and then you're kind of on your own. Okay. And you are allowed to work in groups. I don't really care how large the groups are, unless if I find that, you know, a group is 30 students, then I guess you can do that. That's fine. But I don't really see you gaining a lot from that. But that's totally fine. Like I said, you can totally do this alone, but it might be nice to work with other people. Okay. And so you will be allowed to submit and work as a group right? And no limit to group sizes. I'm not going to put you in groups. Oh, for the lab, for the new lab assignments. So you will be allowed to submit and work. I guess I have to clarify here. For the upcoming labs. You can absolutely do it by yourselves. It's very reasonable, but if you end up working with people, I would prefer that you only submit one document so I don't have to read the same document over and over and over again. It's a waste of my time, it's a waste of your time. And so, but you are absolutely allowed to work on it by yourselves. It's very reasonable. You can do it alone. And so I just don't want to read the same document over and over and over again is the thing. So it's something that I'm trying, and we'll see how it goes. I reserve the right to change my mind, but we'll see how it goes. I've done this in a different class and in the past, and it worked out really well. So so we'll see. Okay, but that's just something to kind of get you started. Okay. Good. Let's see here for a little bit of review. We said, okay, well, we talked about, what types of variables can I have? And specifically for numerical variables, how can I summarize the location, which is, the center, and how can I summarize the spread, which is the variability, right? And so just going way back, we talked about different types of variables. Right? And summaries of location, which is the center, and variability, right? And so we spent a good chunk of time talking about the location and the variability. I'm going to try to use that terminology, which is just the center and the spread. For numerical data, right? We talked about numerical data. So for numerical data, okay, and those are going to be key components, right? And what we're going to focus on today is if we have certain types of variables and maybe combinations of variables, then what can I do to just get an idea of the data? How can I visualize the data for different types of variables? What we talked about last day was just one numerical variable, right? And so to summarize one numerical variable, whoops, or maybe I should say, sorry, not summarize, go back, to visualize one numerical variable, we can use a histogram most commonly, or we can use a box plot. Okay. We can use a histogram plot. Lagging there, but I think it's all caught up. Let me check. Get my pointer on there. Okay. So for some reason it's lagging a lot now, but that's okay. Let me know if it gets out of hand. I'll try to keep an eye on it. So to visualize one numerical variable, we can use a histogram or a box plot. Now, what am I looking for? What am I looking at? Well, I'm looking at definitely the shape, right? So if I have a histogram, am I looking at something that looks approximately normal? Or am I looking at a skewed distribution? Maybe is it bimodal, right? Then that's often an indication of two groups being combined that shouldn't be, right? And so that would be kind of setting us down another path. Okay, what are those two groups? How can I kind of tease those out? And so remember, exploratory data analysis is just kind of to get the wheels turning. Okay, what are some of the things that are happening here that I could look at further, right? What can I analyze here? Is there anything happening? Okay, and so for one numerical variable, there's not a ton that we can do, but we can learn a lot from that variable. Okay, and so from a histogram, I guess it's not really review from last day, but I am going to consider it just kind of review in general. So, so from a histogram, right, we're going to look at the shape and the center and the spread. Shape, center, and spread. Right? And so then I can have a normal distribution or a non-normal distribution, and there's lots of non-normal distributions. And I can figure out where the center, where the approximate center is, or the location, I guess, and the variability, right? So here, if we use our new terminology, whoops. So the shape, we're going to start calling the distribution. I'm just throwing that in there. But the shape is the distribution. Okay, the distribution also incorporates the location and the variability. But if we say the distribution looks normal, then that makes sense. Okay, so so the distribution, the location, and the variability. Okay. So that's what we can get out of a histogram. And we're used to doing that. We did a lot of practice in that in Stat 230, and this is all probably feeling very kind of juvenile at this point, right? This is Stat 240. What are we doing? Shape, center, spread for, right? But it's at the heart of numerical variables. As soon as you visualize it, right? Those are the things that you need to be looking at. Okay. Whereas a box plot, it's a little bit trickier, right? Some things to remember for a box plot. If you've made a box plot, then how can we determine the shape? The shape, it's harder to look at, right? But if you have an even, I don't want to say distribution, but it is an even distribution of the boxes, right? So each of those quartiles are evenly distributed, then you have a normal distribution, right? So if the box plot is symmetric, then you can often say that you have a normal distribution. So if it's symmetric, that means it's a normal distribution, or usually I'll say. Okay, so you look for symmetry. Yeah. What are some other things that a box plot can highlight that a histogram doesn't necessarily know, right? It's the outliers. So outliers in a box plot are clearly highlighted using the 1.5 IQR rule, right? We take 1.5 times the interquartile range, and that's the distance that I'm allowed to go without being considered an outlier. Anything beyond those bounds are outliers, right? And so outliers are clearly indicated. And depending on what programming language you're using, if you're using R, I know it uses the 1.5 IQR rule, but you would have to read the documentation, right, to figure out what it's using, because the 1.5 IQR rule is not the only one that we can use. There's nothing that says we can't use 1.6. Right, 1.75, 2, let's go crazy, right? 3.5, oh my gosh, that's crazy, right? And so there's lots of other ones that we could use, but the most widely used one is 1.5. Okay, and so but the outliers are clearly indicated, which is different from the histogram, right? And so remember, shorter distances between lines in the box plot actually means that you have a lot of data, right? Because that's 25% of your data. If we're thinking about the first quartile to the median, for example, right? The shorter distances means that you have 25% of your data. So here, if I have, so shorter, and I'll say distances, kind of in air quotes because it's not technical, but shorter distances indicate what am I trying to, dense data points, right? So shorter distances indicate dense data, right? So for example, if I have a box plot and it looks like this, and let's say I've got these kind of basic whiskers here. Okay. And if I draw my median is maybe down here. What does that mean? It means that 25% of the data here, right, from Q1 to the median. So the shorter distance from Q1 to the median, there's still a quarter of my data here, right? So that means that all my data points are really, really, really tight. Okay, they're all in this length, right? And so here, this means that we have dense data, right? Because it's 25% of the data. Right, between Q1 and the median, you'll always have 25% of the data, right? And we are used to looking at kind of small examples. You know, we don't want to do it by hand for any data sets larger than 15, and so it gets a little bit weird. But once you have larger data sets, you can look at the quartiles and the medians, and you'll know that you'll have 25% of your data between those 2 points, right? And so there you have dense data, whereas here, if you had to go, this data is more spread out, there's still 25% of the data, right? But it took longer to accumulate that 25%, right? And so here, this is more spread out, because it's still 25% of the data. Okay. Okay, so what does that mean in terms of the skewness? That's a great question. In this little example that I have, okay, let me try something. I'm going to take this because we're used to looking at it, and maybe I'll just copy, and I'm gonna paste it here and try to do that. It's really wonky. I'll clean it up. How about that? Because I find that it's hard when, so box plots are typically stacked like this. We can stack them like this, but typically we do them like this, and then I want to turn it like this. Okay. So then I'm gonna delete this here, and oh, I can't look at this thing. Let me straighten it out. Oh, maybe I can't. How do I? I'll just replicate it. How about that? And then I'm going to delete this here. Wait. Okay. So here, this can go and be like that. Okay. So you could use a QQ plot, but so here, right? Remember, you've got, oops, you've got your numbers, right? Your y-axis here. So y, and these are the data points, right? Or sorry, the data values, let's say. Okay. So starting at 0 and increasing. So then if I take this and I flip it and now I make it the x-axis, then this is what we're more used to seeing, right? Something like this, where the x-axis and the data values are now on the x-axis. So it takes a little bit of imagination here. Okay, so if we need to figure out how skewed this is or in which direction it's skewed, because we can tell that it's not symmetric, so it must be skewed, right? And so here, what I'm going to focus on is, okay, if I have from the minimum, and there are no outliers here, but it would still work for outliers, right? Because they're just single points, so we can kind of ignore them a little bit. So here, I have 50% of the data. Okay. And then I have another 50% of the data here. So if I have to imagine that as a histogram, right, let's see if I can pull this off. I would say I have a lot here, and then I have the same percentage of data to there, if that makes sense. Okay. And maybe, sorry, I'm going to do the same thing, but I'm going to kind of cut it down a little bit sooner. Something like that. Okay, so this would be skewed to the right, exactly. Which has been in the chat for a long time, I know, but we had to get there together, right? And then remember, if you want to check for skewness, or rather, if you want to check for normality, you can use things like the QQ plot. And obviously, if you're unsure, you can just make a histogram. And so here, this would be, therefore, it's skewed. Oops. Skewed right. Okay. A lot harder when you just have a box plot, right? So sometimes I'll just do both, right? Kind of consider both. Okay, good. So, good. So that's if you have one numerical variable. Okay. What if you have one categorical variable that you're interested in learning something more about, right? So I'll call this the end of the review here, even though it was more than you bargained for, I'm sure. Where's the end of this page? Oh, I crossed it. You know what? I'm gonna just quickly try to rearrange here, those famous last words, and see if I can maybe keep it on one page. And I did it. Took a little while, but I did it. Okay. So call that the end of the review. So now, what if I want to talk about just one category? Yeah, organized. Yeah, that looks way better. I don't know why I didn't do that from the beginning. Oh well. So now what if I have, so just exploring one categorical variable. Okay. So what we're going to build through and kind of go through are, the options for, okay, so one numerical variable we just talked about, one categorical variable. What if I have two numerical variables, right? Then what are my options? What can I do? What am I looking for? What if I have two categorical variables? Then what can I do? What am I looking for? What if I want to look at a numerical variable and a categorical variable? Then what can I do, right? Then, and what can I look for, right? And then what if I have two numerical variables and a categorical variable? Those are kind of the most common options that we're going to consider, right? And so we're going to kind of build a little farm of graphs, I guess. So if we have one categorical variable, our only real options are a bar graph. Okay, and so so exploring one categorical variable, and we visualize one categorical variable with a bar chart, right, or a bar graph. And what are we looking for, right? We're going to look for the mode. Usually that's the thing that we care about. What group has the highest count or the highest proportion, right? And so so we're going to visualize with a bar chart and look for the mode. And the mode is the category with the largest count or proportion. So the mode is the category with the largest counts or proportions. Okay. Okay. You can talk, sometimes we introduce the mode for histograms, but it's really not interesting for histograms because we have better things. We can talk about the mean, we can talk about the median, we can talk about how they relate to each other, right? And so now when we talk about the mode, it's usually for categorical data. And so we can visualize with a bar chart. You can look at things like a pie chart, but if you have been in my class before, I hate pie charts and I don't want you to use them, right? And so, and I can go on and on about how bad they are, but it boils down to our eyes can't see that area as well as we can see differences in heights. Right. And so our brains don't work that way. And so we're kind of working against what a visualization should be, right? It should be easy to look at. It should be brief, and easy to just look at it and understand what's going on there. So that's my beef with pie charts. So I don't want you to use pie charts. Stick to bar charts as much as you can. Okay. You'll be tempted. You'll be tempted, but I say no. Okay. And so for one categorical variable, there's really very little that you can do. So to visualize it, you're going to make a bar chart. To summarize it, what can we do? We can make a table. We can make a frequency table. Okay. So to summarize one categorical variable we use a frequency table, right? So we use a frequency table, right? Which could also be a proportion, a table of proportion, or what's that called? Prop.table, proportions. And I'll just put counts or proportions here. The name for the proportion, the table of proportions is escaping me now, but that's okay. So we can use a frequency table with the counts or the proportions, and that's really the information that we take to make a bar chart, right? A bar chart is just a visualization of that frequency table, right? How many things are in each category, and there's really not more that we can do there, okay? And so what can we do that's a little bit fancier? So if we can associate a value, so a numerical value with a category, what we can do if we know the probability of each category happening, right? Or if we have the proportion in each category, that is a probability, right? Proportions and probabilities and percentages, they're all used interchangeably, right? And so what can we do? We can find the expected value, even for a categorical variable, which is a little bit weird. So what I want to say here is if the categories can be associated with numerical values, right? So it can be associated with numerical values, like things like on a scale of 1 to 5, how do you feel about this, right? So for example, on a scale of 1 to 5, oops, shouldn't use the word for one and then the number for the other. So right, on a scale of 1 to 5, those are categories, right? That's a categorical variable, but now I have these numerical values that I can associate with a category, right? So if the categories, so that's a big if, can be associated with numerical values, and so I'm going to highlight all the things that we're assuming here, or that it kind of hinges on. So, and we know the probabilities or the proportions of each of those categories. So, and we know the probabilities or proportions associated with each category. We can calculate the expected value, and the expected value is a mean, okay? And that's kind of weird. So it is an average. It's an average category, okay? And so it gets a little bit weird, but that can be important, right? If the average category on a scale of 1 to 5 is 1.5, then those are typically very low scores, right? That tells us that, okay, overall people are feeling kind of low score about this, whatever that means. Okay, and so that is a summary that we could use, but notice it hinges on, okay, the categories have to be naturally associated with some number, right? And we have to have the probabilities of each of the categories or the proportions in each category. Okay? And so, so if the categories can be associated with numerical values, and we know the probabilities associated with each category, we can calculate the expected value which is really just the mean category Oh, I see it's lagging again. Sorry, guys. Let it catch up. It's trying its darndest not to. Weird. Okay. So that's what the expected value is. And the expected value is going to come up later as well, but it's most useful if we have different probabilities associated with different values. Then we can still find the mean. It's a weighted mean, right? And that is what the expected value is. But the expected value for us in general is what we're going to call the mean eventually, right? So the expected value is just a mean. But in this particular case, when we're talking about a categorical outcome, it's the mean category. Okay. Okay. So that's if we have one categorical variable. Okay. Let's move to two numerical variables. Then, okay, so now I'm looking at a relationship between two numerical variables. So I'm gonna just write it as two numerical variables. Okay. So now, instead of just summarizing one thing, right, what's going on with this one piece of information, now I'm looking at more at the relationship between two variables, right? So as soon as I'm looking at two or more variables, I'm looking at their relationships. So now we consider the relationship between, in this case, two numerical variables. Between two numerical variables. Let's start with how to summarize it. So to summarize the relationship between two numerical variables, our obvious first stop is going to be a scatter plot, right? If I have two numerical variables, then I can have, you know, my axes are actually numerical, and I can make that work, and I can graph them, and we know what a scatter plot looks like, right? And so to visualize it, we're going to use a scatter plot. Okay. I'll introduce some other ones, but a scatter plot is kind of at the heart of everything. Okay, and so, and the other ones, let me just confirm, but they're just glorified scatter plots. Okay, so I'm just going to say scatter plots, and then I'll introduce some other ones later, but they are just glorified scatter plots. So at the heart is just a plain scatter plot, and then we add more information if we want to. Okay, so we're going to visualize using a scatter plot, and if we have a linear relationship, then we're going to talk about the correlation. In fact, we're going to talk about the correlation for any relationship as if it's just the strength. And the only reason I'm specifying is because the only correlation that we have seen so far is the Pearson correlation coefficient, which is only for linear data. But we can talk about the correlation for other relationships as well. And it is just how strongly are these things related, right? And so we can visualize it with a scatter plot, and then we can summarize it. We can summarize the relationship, specifically the strength, using the correlation. So, and then we summarize the correlation is a measure of the strength of the relationship. Okay. There are things that we know, right? So correlation is on a scale from -1 to +1, where 0 means that there's no relationship. And then we can have negative relationships or positive relationships that are equally strong as we move out towards 1, right? And so here, we're going to have kind of a number line here. So correlation can be between 0 and -1 and 1. And kind of go cold here, right? So it's the strength. This is a negative relationship. And the strength increases as you move from 0 out to -1, and it's going to be negative. And then how can I do a positive? I'll do orange. Same idea. The strength is increasing, and this is a positive relationship. Right. And then here, at 0 correlation, there's no relationship. Okay. So that's just a reminder of the correlation, and that's going to stay the same. I think I simplified things, or I know I simplified things a lot by saying, okay, a rough cutoff that I would use is 0.5. So if you're beyond -0.5, for example, then you have a strong negative relationship, and 0.5 on the positive side, again, you have a strong positive relationship. I'm going to ask you to be a little bit more specific now. So we're going to talk about moderately strong, moderately weak, right? And so, but that's also just subjective, right? What do you see? Do you think that 0.4 is strong or weak? And so I don't want to give you any guidelines, but I want you to kind of introduce some of that more colorful language, if that makes sense. And we'll get there. But for now, right, how we summarize the relationship between two numerical variables is just with the correlation. Okay. And for now, let's just focus on linear relationships, but in general. So you're going to use a scatter plot, and then how we can kind of summarize that relationship is with the correlation. Okay. What are some other things that we can do? Right, so some other options. There are other visualizations. Okay. And I'm going to say that they build on the scatter plot, right? So that build on the scatter plot. Oops. Some of those things are, let me see here, hexagonal binning. Ooh, okay. Let's see here. hexagonal binning. What's that going to look like? Well, it's going to be a scatter plot. Okay, so it is, like I said, they're all built on scatter plots. Okay, but what happens is there's little, and I can't remember what a hexagon looks like. Hexa, so that's 6. How many sides does a hexagon have? Should be easy enough, but I don't remember. Where is it? 1, 2, 3, 4. It is 6. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And then you would keep going. And so this would replicate just across the entire grid. Okay. And then what would happen is okay, so I should have just checked the chat. It's 6 instead of having to count them out. Anyways, thank you. So I was getting there. Hexa 6. Yeah. So then each little region would have its own bin. This sounds familiar, right? This is basically a histogram, but now taking into account 2 numerical variables instead of just 1 and creating bins, right? And so each hexagon is a bin, okay? And so now each hexagon, hexagon is a bin, okay? And then we can do fancy stuff like to show how many things are in each bin, right? Each hexagon, we can increase the contrast, right? We can increase the darkness in each hexagon depending on what the count in each bin is. So we kind of build them up gradually as if we have a histogram, right? A histogram has all these bins and we fill those. And same thing with these hexagons. If they're in each bin, then we kind of build them up, not in a 3D kind of way, because that would be weird, but in a color scale kind of way, right? And so the color scale of the hexagon would indicate how the count in each of those bins. Okay. But this is basically just like a 2D, or this is basically like a histogram for 2 numerical variables, right? So that's one thing that we can consider, right? Because so each hexagon is a bin and each observation is placed in a bin, and each observation, right, which is a pair. Yeah, and if you have a look in the textbook, they do show a hexagonal binning chart, and we're going to make one too, of course, because they made one, we make one. And so in the lab, you'll make one, and they are really pretty, really nice to look at. So glad you like it. So, and each observation is placed in a bin. In a bin or a hexagon. Okay. Good. Because sometimes what you're going to find is that when you have a scatter plot, and if you have a huge data set and you end up making just a scatter plot, a normal scatter plot, and then what you're going to find is that it's really hard to tell how many points are on top of each other, right? And so it's just going to be this dark mass. As soon as you get up to larger data sets, it's going to be just kind of hard to see what's going on there. And so, and maybe that's not something you're concerned with, right? Maybe you're just looking at the relationship, but maybe, right, you want to incorporate a little bit more information, like how many things are in each of those regions, those kind of blacked out regions, because as soon as you have one dot, it's filled, right? So then you could use a hexagon or a hexagonal binning chart, I guess. Okay. What's another thing that you could do, kind of similar in my opinion, is a contour plot and also a heat map, right? We're going to talk more about those, and we're going to work through those in the lab. So, and we're going to recreate them. And so, so I'm going to kind of parking lot those, but they're all very similar, right? So you might have seen a heat map before, and same idea, right? There's lots of activity here and not so much activity here. So you kind of get this kind of hot and cool color scheme typically, right? And so, and then it'll kind of show, okay, there's a lot of activity here, but that's basically hexagonal binning again, right? And so, and same thing with the contour plot. The contour plot kind of outlines, you know, you've got most of the data here and then here and then here. And so, but they're all based on just scatter plots, right? And kind of just the scatter plot reimagined. What if I have, so that's for two numerical variables. Sorry, I scrolled up and now it's lagging. So that's for two numerical variables. What if I had two categorical variables, right? Before we get into talking about combinations of the two. Okay. So what if I have, let it catch up here, two categorical variables. If I have two categorical variables and I want to look at the relationship between the two, and usually we end up talking about the association between the two, but that's okay, right? Again, we're going to look at the relationship between the two. And so, right here, we're looking for the relationship between two variables, two categorical variables. Usually when we're talking about categorical variables, rather than just thinking about the relationship, we want to think about the dependence, right? Does being in one group depend on whether you're in a different group or not, right? And so here, usually we talk about dependence, usually. Okay? But in general, if you say relationship, you're safe. Okay. So okay, so now what are my options? We're kind of limited. Again, for categorical variables, there's very little we can do. And so, or reasonably do. So we're going to look at contingency tables. Now, those could be proportions or they could be raw counts. Often we're just going to go straight to proportions, but we could consider raw counts. But again, it's one of those things that our brains don't handle that very well. We don't look at raw counts and just know how they relate to one another. Whereas if I tell you that 30% are in this category and 40% are in this category, then I know how they relate to each other. Whereas if I tell you that, 64 out of what's reasonable out of 310, right? Our brains don't do that easily. So again, we usually use proportions, right? And so a contingency table, so to summarize, and how did I do that? Which order did I? We visualize, I'll start there. How do you visualize the relationship or kind of the relationship between two categorical variables? My go-to is going to be a bar chart. So it can either be stacked or it can be side by side, right? But we can do a more complicated bar chart, right? And so it can be a bar chart. And we have a couple of options. It can be stacked, meaning that a bar, right? So category 1, maybe I'll do this. Like this. Okay, so what it would look like is if it's stacked, it might look something like this. Okay. What do I have here? I have one categorical variable that's been split up, right? So one categorical variable is summarized by the height of the total bar. And then what I've done, the stacks are the second categorical variable, right? So the categories in the second categorical variable within the underlying categorical variable, right? Or category. And usually we talk about proportions here, right? And so, so in this case, yeah, so my first categorical variable has 2 categories, right? Category A and B. That's my first variable. And then my second categorical variable has 3 different groups, right? And so then my variable number 2 has the pink group, it has the orange group, and it has the green group, because I'm hesitant to call them, you know, group 1, group 2, group 3. And so here, this is my variable number 1, right? So now, what would this look like if I had to summarize it? Then it would look like a 2x2 table, right? I would have variable 1 with category A and category B, and then I would have variable 2, variable pink, orange, green, that kind of thing. Okay. So that's a stacked bar chart, or I can have a side by side. So I prefer a side by side bar chart. I don't know. I just find that it's a little bit easier to look at. So then it would have kind of a pink cluster and a pink cluster and an orange cluster, which seems to be lower. I made these kind of way too small, but that's okay. And I'm trying to follow what I did there. Oops. Okay. Same idea. It's just whether they're stacked or not. I prefer the side by side just because then again, it's easier for me to compare within each group, right? The pink versus the orange versus the green. Okay. So to summarize this, and I mean, there are other options, but these are kind of the ones that we're going to stick with. We don't really need anything more than this. Okay, so to summarize, I can summarize this using a contingency table. Right, and it can either be of the counts, but prefer the proportions. Okay, proportions or percentages, but it gets tricky sometimes in R, especially for percentages. You would want to have the units, so then you'd have to have that little percentage, which then it reads it as text and it gets a little bit messy, but you definitely can. And for reporting purposes, you would probably want to use percentages instead of proportions. So maybe I'll do that here. Or percentages. Okay. So what does that look like? Well, it looks like this. Using the same fake example that I had earlier, right? I have variable number 1, which has category A or category B. And then I have variable number 2, which has either the pink or the orange or the green, right, as its categories. And so this would be a 2x3 table. Yeah. And you can do things like you can have the totals in the margins, right? And just depending on how much information you want to have. Now, if you've worked in Excel at all, you're probably familiar with pivot tables, right? And they are just contingency tables. And if you have really played around with it, you know that you can have more than 2 categorical variables in there, but it makes it really hard to see what's going on. But you can. Okay, so here, maybe I'll do it in, I'm running out of colors here, but maybe I'll do it in gray, right? I can have the totals and the totals, right? We can add the totals in the margins if we want to. I never use this gray pen. Looks fun, but maybe it's hard to read. I don't know. I see it okay though. I won't use it anymore. It's just like one of those ghost things, like we can add the totals if we want to. Okay, so good. All right. So what was the last thing? What was the last thing that I wanted to write down here? I said something else. Oh yeah. These are pivot tables in Excel. If you're familiar with Excel. Right? I think industry kind of assumes that you are proficient in Excel. Okay, so even if you haven't worked in Excel, you're going to pick it up so quickly and just, you know, do a couple of practice courses and you'll be fine. Excel is good, but it's not hard. So I'll focus on teaching you the hard stuff, sort of. Okay. So we've talked about 1 numerical variable, 1 categorical variable, 2 numerical variables, 2 categorical variables. What's next? What if I have a numerical and a categorical variable? Uh-oh. Okay. So what if I have one numerical variable and one categorical variable? How can I'm going to focus on visualizing this, because for the summary, we'll get there, but it's not as clean, right? So to visualize, we've got a few options, right? We can make a histogram or a box plot, and we can split them up by the categories. But usually making the box plot, a side-by-side box plot, is the easiest way to do it. So we can make a histogram or box plots for each category, or side-by-side box plots, right? So that's what I prefer, side-by-side box plots, right? And that's what I prefer. What I prefer, because it allows us to compare the groups on the same scale. What I prefer, because it allows comparisons across the groups on the same scale. Okay, so what that's going to look like is like this, right? So here I have my numerical variable scale. And then what I have is I have a box plot for category A and category B and category C, right? So here, these are my categorical variables. And let's just say, if I draw these boxes quickly, and these are just hypothetical, but now it's easy for me to see, and I can compare things like the minimums, the maximums. I can talk about outliers. I can talk about how the medians compare to each other, right? I can say things like, oh yeah, all of the data in category B is less than even the minimum in category C. That's a huge observation, right? And so now I can compare these different numerical groupings by the categories. Okay, so that's good. Okay, we can do things like violin plots, and what's the other one that I'm thinking of? That's probably good. Violin plots are a little bit more specific. They're like fancy box plots in the sense that they show the density as well. So instead of just showing, okay, here's 25% of my data in this stretch, you figure it out, right? The violin plot is going to have this kind of, okay, here, and then we get more data here, and then less data here, and then more data here. So it shows the density as well. So we could also consider a violin plot which is a box plot, is a side-by-side box plot. And I guess you could do one violin, but we don't really do that because it's too fancy for just one variable. So if we have multiple categories that we want to compare, then we can make these violin plots, and they're just showing the density instead of just boxes. So we could also, I'll say use, I missed the word there. We can also use a violin plot, which is a side-by-side box plot. But instead of just the boxes, it shows the density as well. But instead of just the boxes and whiskers, the whiskers are those little, well, they're the whiskers on top of the boxes on the bottom and the top. So it shows the density. It shows the density of the data as well. Okay, so instead, and I would never draw this by hand, I just want you to see what it would look like. A, B, C, maybe it would look something like, I did not do that well, but it kind of ends up looking like a violin. Maybe it's like, they're supposed to be symmetric, but it's really hard to draw. I think you understand though. Something like that. Okay. Good. So that's if we have one numerical variable and one categorical variable. The other option that we could consider and easily graph is if we have two numerical variables and one categorical variable. So what if I have two numerical variables and one categorical variable? We can go on, but beyond this point, it gets a little bit weird, and you would just do different versions of this multiple times over, considering other variables, right? So two numerical and one categorical variable. Oh my gosh, what are we going to do here? Well, it's okay, right? What can we do? Well, for two numerical variables, we're going to make a scatter plot, right? Or some version of a scatter plot. And then if I incorporate a categorical variable, then what can I do? I can split those scatter plots by the categories, right? And then I have these individual scatter plots essentially, right? So I'm saying scatter plot, but that incorporates things like the hexagonal binning and the contour map and the heat map, right? And so in general, I'm calling those scatter plots, right? But we can visualize by making a scatter plot that's broken up by the categories. Okay, make scatter plots for each category. All right. Scatter plots, which I said includes things like or hexagonal binning, a contour plot, or a heat map. But you would break it up by each category, right? And so just to keep it on this one page, because I know I'm all out of time, is you would have kind of a scatter plot for category A, you would have a scatter plot for category B, and another one for category C. Right, so one scatter plot for each, and that's good. Oh yeah, and you'd have an X and a Y. X and Y are numerical variables, right? And then categorical variables, the categories here in this fake example are A, B, and C, right? X and Y, X and Y. Okay, awesome. So that is great. We finished with just a moment to spare. If you have any questions, let me know. Otherwise, I hope you have a great weekend, and I'll see you next week. Stop this recording here.